All right, so now let's talk about ozonolysis reactions with alkynes. Remember, ozonolysis, this was using ozone or O3, and we saw that that cleaved the alkenes, cut it straight down the middle and gave us two new products. We're going to see the exact same thing with our alkynes, except instead of producing aldehydes or terminal carboxyl groups, we actually form carboxylic acid groups. Okay, so just like we saw before, we cleave right down the middle of that carbon-carbon triple bond, but instead of producing aldehydes, we now have carboxylic acid groups that have been formed. Okay, and I guess just to color code to hammer things home, right? This is one side formed this molecule, and the other side formed that molecule, right? So you're going to get two new products out of it. It turns out that if it's a terminal alkyne, you indeed get, from the one half, you do get your carboxylic acid, right? So this corresponding to that half of the molecule, again, cleaving right down the middle. But for this carbon here, instead of getting a carboxylic acid, you actually get CO2. And that's just because this compound right here doesn't really exist, even if there was a hydrogen there. It'll quickly rearrange itself and form carbon dioxide, okay? So with a terminal alkyne, you get a carboxylic acid and carbon dioxide. For an internal alkyne, you get two carboxylic acid products. But just like we saw with alkenes, the ozonolysis reaction is all about chopping that triple bond. Okay, if we're going to predict products for this reaction here, all right, again, what are we going to do? We're going to chop that triple bond there. And this carbon on either side is now going to have a carboxylic acid group associated with it. One of the things that I want you guys to make sure you're doing is counting carbons. That's the easiest way to make sure that you're not messing anything up. All right, so 1, 2, 3, 4, 5-membered ring. Cool, and then one carbon sticking off, and that's the carbon that has that OH group. Notice that on this other side, have the exact same thing. Since this is a symmetrical alkyne, what I'll have is just two equivalents of that same carboxylic acid product that's formed. Okay, so symmetrical alkynes will produce, both sides will produce the same thing. So it's a great way to produce carboxylic acids where you don't have this mixture where you're going to have to separate them out. Okay, so it's pretty straightforward for the ozonolysis. Again, nice thing about the mechanism is we don't know it. We're not going to bother with it. This first was green, and I looked up the spelling. It is an I. In terms of the regioselectivity, strictly speaking, there isn't any regioselectivity other than to note the difference between an internal, which again just produces two carboxylic acids, and a terminal, which will produce CO2. That's not technically regioselectivity, but it seems like we should put it in that category. All right, and then stereoselectivity. No, don't have to worry about it. Okay, so not too bad. Just like before and the practice that we have after this, I think the harder part is kind of working backwards. And so that's one of the things that we're going to be practicing in the assignment that's after this.